consumer buys 2 extra packs of paper towels at a local grocery store. It is a microscopic event, statistically insignificant on its own. Yet, in a traditional system, this tiny fluctuation triggers a localized panic. The store manager orders 5 extra packs just in case. The regional distributor, seeing a sudden spike across multiple stores, orders 50 extra cases from the wholesaler. By the time this signal reaches the paper mill, that initial purchase of 2 extra packs has mutated into an urgent, panicked production order for 500 cases, throwing the factory floor into complete disarray. This is the bullwhip effect. For decades, it has been the fundamental vulnerability of global supply chain management. A slight twitch in consumer demand at the retail level amplifies as it travels upstream, creating massive oscillations in manufacturing and procurement. It is a chain reaction of human anxiety and delayed information, forcing every node in the network to second-guess the node below it. The result is a chaotic pendulum swinging between severe shortages and overflowing warehouses. The root cause of this instability was never a lack of resources, but a critical failure in visibility. Traditional logistics forecasting methods rely entirely on lagging indicators. Planners build their models on historical sales data, seasonal averages, and last quarter's performance metrics. They look backward to predict the future. When a sudden market shift occurs, these static models shatter, leaving companies blind and forcing them to rely on intuition rather than intelligence. They are effectively driving a high-speed vehicle while looking exclusively in the rearview mirror. This blindness carries a devastating financial cost. When forecasting fails, companies are forced into a binary trap. They either engage in costly overstocking, tying up millions of dollars in capital just to maintain a buffer, or they suffer damaging stockouts, losing revenue and eroding customer trust. For legacy operators, the cost of doing business meant accepting this inherent inefficiency as an unavoidable law of physics, a tax paid for operating on a global scale. That paradigm collapsed the moment artificial intelligence entered the logistics equation. The pivot occurred when industry leaders abandoned reactive forecasting and integrated real-time AI demand sensing. Instead of waiting for sales data to trickle up the chain, these new neural networks actively monitor the ecosystem. They ingest massive, non-traditional data sets that human planners could never process at scale, fundamentally changing how the network perceives time and risk. Demand sensing operates on an entirely different architectural premise. These systems continuously absorb raw, unstructured inputs from the edges of the economy. They analyze real-time social media trends, localized weather patterns, satellite imagery of parking lots, and live port congestion data. By mapping these disparate signals, the AI detects the earliest tremors of consumer behavior long before a purchase is ever made at a cash register. This is a transition from linear extrapolation to multidimensional pattern recognition. Within the latent space of these machine learning models, seemingly unrelated data points reveal hidden correlations. A sudden drop in temperature in the Midwest, combined with a viral video trend and a minor delay at the port of Long Beach, synthesizes into a highly accurate prediction regarding the demand for a specific winter garment in Chicago. The practical application of this technology allows systems to predict demand shifts before they propagate upstream. When the AI detects a genuine spike in consumer interest, it does not panic. It calculates the exact volume needed and transmits a calibrated signal directly to the manufacturer, bypassing the layers of human distortion. The bullwhip is cracked before it can even swing, neutralizing the volatility at the source. This fundamentally alters the daily reality of procurement teams. The era of staring at endless spreadsheets and manually tweaking safety margins is over. Logistics professionals now operate as supervisors of automated systems. They establish the parameters, define the risk tolerance, and let the algorithm execute the micro decisions. The human role shifts from data entry to strategic oversight, trusting the machine to handle the mathematical heavy lifting. The immediate measurable outcome of this integration is a drastic reduction in safety stock requirements. Because the AI provides a high-fidelity picture of actual demand, companies no longer need to hoard inventory as a defense mechanism against uncertainty. The buffer zones shrink. Warehouses that once served as expensive holding pens for dead capital are transformed into agile transit hubs, moving goods only when specifically required. Stripping away this excess inventory leads to a significant increase in inventory turnover efficiency. Capital that was previously trapped on dusty shelves is suddenly liberated, ready to be deployed into research, development, or expansion. Products flow through the network at unprecedented speeds, arriving exactly when needed, maximizing shelf life and minimizing depreciation. The entire financial profile of the enterprise becomes leaner, more aggressive, and highly responsive to market realities. Unlike legacy software, these demand-sensing algorithms are continuous learning models. Every prediction they make, whether accurate or slightly off, is fed back into the system to refine the next calculation. When a supply chain shock occurs, the AI does not break down. It instantly recalibrates, adjusting its weights and biases to account for the new reality, ensuring that the network remains resilient under pressure. This marks the definitive end of the static reorder point. In the past, a system would automatically trigger a purchase order the moment inventory dipped below a hard-coded number. Now, inventory thresholds are entirely dynamic. The AI constantly adjusts the reorder point based on real-time variables like current transit times, supplier capacity, and fluctuating commodity prices, ensuring maximum efficiency at every given second of the day. Management moves from continuous manual oversight to pure exception management. The AI handles 99% of the routine supply chain operations autonomously. Planners only intervene when the system flags a severe anomaly that requires human context, such as a geopolitical crisis or a sudden regulatory change. This hyper-focus allows small teams to manage global networks that previously required armies of analysts. By eliminating the noise and distortion, AI is fundamentally stabilizing the flow of goods from manufacturer to shelf. The panic ordering cycle has been neutralized. Suppliers receive steady, reliable production schedules, allowing them to optimize their own operations and reduce waste. The entire ecosystem operates in a state of synchronized harmony, driven by empirical data rather than collective anxiety. Yet this level of automation introduces a new category of vulnerability. As companies strip away their safety stock and rely entirely on algorithmic precision, the margin for error approaches zero. If a demand-sensing model hallucinates a trend or misinterprets a data cluster, the resulting automated decisions can cascade through the network with devastating speed, creating a self-inflicted supply shock that is entirely digital in origin, crippling operations faster than any human planner could intervene. This is why the most advanced logistics networks do not grant AI unchecked autonomy. They engineer robust guardrails into the architecture. Confidence thresholds dictate when the machine can act independently and when it must request human authorization. Balancing the raw speed of automated execution with the strategic intuition of experienced planners is the central challenge of modern supply chain architecture. The true test of these hybrid systems occurs during unprecedented global disruptions. When major shipping canals are blocked or unexpected labor strikes paralyze key ports, historical data becomes entirely useless. The AI must instantly ingest the new constraints, calculate alternative routing options, and reallocate inventory across the hemisphere in real time, preventing a localized bottleneck from triggering a global collapse. This capability is driving a rapid consolidation of market power. The divide between logistics companies utilizing advanced AI and those still relying on traditional forecasting is widening into an unbridgeable chasm. Legacy operators simply cannot match the speed, efficiency, or resilience of their automated competitors. Superior demand sensing is no longer a competitive advantage. It is a strict prerequisite for survival in the modern economy. Investors are actively punishing firms that fail to modernize their predictive infrastructure. Consequently, the professional requirements for supply chain managers are undergoing a radical transformation. The industry no longer values the ability to manually balance a ledger or negotiate a freight rate based on intuition. The new currency is data literacy. Professionals must understand how to query the models, interpret complex probabilistic outputs, and audit the algorithmic logic to ensure the system remains aligned with broader business objectives. The introduction of large language models is accelerating this evolution even further. Generative AI serves as a translation layer between complex logistics databases and human operators. Instead of writing complex SQL queries to understand a supply bottleneck, a planner can simply ask the system natural language questions. The AI instantly synthesizes the data, generating clear, actionable insights regarding alternative supply routes and inventory rebalancing strategies. This capability enables zero-shot inference in supply chain shocks. When an entirely novel event occurs, one with absolutely no historical precedent, the AI can still reason through the problem. By drawing on its vast pre-trained knowledge base of global trade mechanics, economic principles, and logistical dependencies, the model can propose viable solutions to problems it has never explicitly been trained to solve. The impact is a massive compression of reaction time. What previously required weeks of cross-departmental meetings, frantic spreadsheet analysis, and delayed executive approvals can now be executed in seconds. The AI identifies the disruption, formulates a mitigation strategy, and presents the optimal path forward before the human operators even fully grasp the scale of the initial problem. The speed of resolution becomes a core metric of corporate competence. We are witnessing the rewiring of the global economy. A supply chain optimized by artificial intelligence is inherently less wasteful. It requires fewer raw materials, consumes less fuel for transportation, and generates a significantly lower carbon footprint. By aligning production perfectly with consumption, these systems are quietly solving some of the most intractable environmental and economic challenges of the industrial age. For the logistics professional, this represents a profound elevation of purpose. Liberated from the endless cycle of reactive firefighting, they are now free to focus on proactive architecture. They design more resilient networks, forge strategic partnerships, and explore new markets using AI, not as a replacement for human ingenuity, but as a massive multiplier of their strategic capacity. They are no longer simply moving boxes, they are engineering the flow of global commerce. The bullwhip effect was never a permanent fixture of commerce. It was simply an artifact of an era where our reach exceeded our vision. We built global networks but lacked the nervous system required to govern them. Artificial intelligence has provided that nervous system. By turning chaos into calculable data, it has finally stabilized the supply chain, proving that the most complex economic problems require the most sophisticated technological solutions.